Okay, we're starting topic 3. Topic 3, 3-1, multiplication properties. In your notebook, in the table of contents, whichever number it might be, go ahead and add multiplication properties. I know mine says 5, yours may be different than mine, and that's okay. So go ahead and add that in your notebook. Throughout the videos, remember you can pause at any time, but you have to get the notes done in the time that we have. So make sure you're not pausing the entire video, you're getting your things together to be able to get your notes all taken care of. Writing multiplication properties. Turn to your next clean page. The holes are on the left-hand side here. Oops. On the left-hand side here. We're going to write our I can statement. Our title is multiplication properties. This is going to be properties that all multiplication has, no matter if you're multiplying a big, huge number or small numbers. Multiplication properties will always be in place. Our I can statement, I can understand how multiplication works. By knowing these properties, we can determine how that multiplication works. This part you do not need to write down. It's okay. You don't need to write it down. The next part that I write in here, you will need to write down. And hopefully you can do it before I even get to it. So here we go. One class has 3 rows of 6 desks. There should be an S there. Another has 6 rows of 3 desks. What multiplication sentence can give you the total number of desks in each room? Well, to solve this, we're going to go ahead and draw a picture. That's my very favorite way that we solve word problems like this. So the way that we're going to solve this one is by drawing a picture. We're going to start with this first one. We want 3 rows. So our rows will go like this. Nope, those are columns. Let me just erase those. 3 rows. Our rows will go like this. And there's going to be 6 desks in each. 1, 2, 3, 4, 5, 6. This type of picture is called an array because we have the X's to mark where the desks are going. And so we have going across, we have 6. And going up and down here, we have 3. So there's our first row, or first array, 3 rows of 6 desks. Now another classroom has 6 rows of 3 desks. So they're going to have 1, 2, 3, 4, 5, 6 rows, and each row is only going to have 3 desks in it. So the after we get this array drawn, what number sentence could we write for each one to show how many desks are in each room? When we're dealing with multiplication, it's going to be groups. So in this one right here, the red one, we have 3 across. You see how it's lined up. So we have 3. There's 3 here, or 3 across in each one. So we have 3. And we have 6 going up and down, 6 rows. So for this array, we can do a number sentence of 3 groups. Oops, I should change back to my black marker. 3 groups, because this is a group of 6. And when I use the word groups, I'm going to use the time sign. So I have 3 groups of 6 in that one. Over here with this red one, I have 6 groups of 3, because a group is this one right here. So we could write this 2 different ways, but if we counted each one of those X's in the arrays, we would still come up with the same amount, because in multiplication, it doesn't matter if we put the numbers like this or if we put the numbers like this. We still have a 3 here and a 3 here. We still have a 6 here and a 6 here. They're going to equal the same amount. So 3 times 6 here, if we count our X's, 1, 2, I'm gonna get my pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 in this one. And then over here, in the red one, even though they're in 6 groups of 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. They're in 2 separate arrays, 2 different arrays. The black one is in 3 groups of 6, and the red one is in 6 groups of 3, but they're going to equal the same amount. This is true of all multiplication. This is because of the commutative property of multiplication. The commutative property of multiplication says that the orders of the numbers do not affect the outcome or the product. So if I have 2 times 4, it's going to equal 8 just the same as 4 times 2. I can flip-flop my numbers, whatever order they're in does not affect the outcome. So if I had 7 times 3, it's going to equal 21. If I had 3 times 7, it's still going to equal 21, and I could draw the array for it. This one's going to be 7 groups of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I have 3 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3, and way down here at the bottom, 7 groups of 3. There's still going to be 21. Different. The array looks different over here. This is going to be 3 groups of 7. So I'm going to have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this has 3 groups of 7. This one has 3 groups of 7. This one has 7 groups of 3. It's still going to equal 21. Does not matter the order of the numbers. Another one of the properties is called the associative property of multiplication. This says that the numbers can be grouped to be multiplied, but it will not change the product. So in my number sentence I have here, I have not grouped the numbers. They are all individual. 2 times 3 times 5, 2 times 3 times 5. But I'm going to group them. I'm going to put parentheses around them. And I'm going to say, okay, this one I'm going to multiply the 2 times the 3 first. And this one I'm going to multiply the 3 times the 5 first. Let's see if we get a different answer. Parentheses in any sort of math problem say, I do that first. That is the very first kind of math that I'm going to do. So over here, if I have 2 groups of 3, 1, 2, 3, 1, 2, 3, I have 6. And then I'm going to take that 6 and I'm going to multiply it by the 5. So now I need 6 groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 4 groups. 5 groups of 5. I need 6 groups of 5. And when I count them all up, I have 30. So that was my first problem. I get 30 here. Put it up here. This one I did the math and I got 30. Now I go over here to my other problem. I'm going to multiply 3 times 5, 3 groups of 5 here. 1, 2, 3, 4, 5, making an array. Three groups of 5 is 15. Woo-wee! And now I have to multiply by 2. Man, that's a lot of X's that I need to draw. All right, to make this array, I need 2 groups of 15. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! Almost there. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2 groups of 15. If I add this all up, guess what I'm going to get? It's going to be 30, guys. I'm just telling you. The associative property says I can group the numbers however I want. The problems looked different. I was making different kinds of arrays, but both times I came up with an answer of 30. This is called the associative property of multiplication. I can group the numbers and they're still going to be the same product. This one I hope that you know really, really well. This is called the identity property of multiplication. When a number is multiplied by 1, the product is the number. That sounds all complicated, but really all it says is when I multiply a number by 1, I get the number. So 3 times 1 is 3, 12 times 1 is 12, 681 times 1 is going to be 681, and 27 times 1 is going to be 27. No matter what I do, if I multiply by 1, I'm going to get that answer. So I could put it into this form. The identity property says A times 1 is going to equal A. A just stands for any number. A for any number. Any number times 1 is going to be A. Here's another property that you should know by heart. If you multiply anything by 0, the answer or the product is going to be 0. This is called the 0 property of multiplication. 3 times 0 equals 0. 12 times 0 equals 0. 681 times 0, 0. 27 times 1, oops, that should be a 0. What was I thinking? I got carried away. I was thinking of the identity property. 27 times 0 is going to be 0. We could write this up. Any number times 0 is going to be 0. It will always work. Because you can't have, if you're putting items into groups, you might have, for this first one, 3 groups, but you have nothing in the groups, you're going to get 0. If you have 12 groups of nothing, you're going to get nothing. If you have 681 groups with nothing in them, you're going to get nothing. If you have 27 groups, nothing in those groups, you're going to get nothing. Okay, I want you to tell me which property I'm showing when I do this. If I have 65 times 1 equals 1, which one of my properties is this going to be? I have commutative. We'll just do a code. Commutative, where I can move the numbers around. Associative, which means I can associate the numbers and multiply them however I want. Identity property, where I multiply by 1, and the property of 0, where I multiply by 0. So this problem right here, 65 times 1, they already give you the answer. They're looking for which property it's going to be. So this one's going to be the identity property. If I have 11 times 9 is the same thing as 9 times 11. 11 groups of 9 is the same thing as 9 groups of 11. Which one of my properties? I moved them around, so it's going to be commutative. Next one, if I have like 8 times 4 times 3 compared to 8 times 4 times 3, this one's going to be the associative property. And finally, if I have 0 times 32 equals 0, this is going to be the 0. All right, if you need to go back in this and pause the video, that's cool. If you are all ready to go, wait patiently while I'm finishing up with my group. We're going to be working on some of this at the table. So, as always, happy mathing.